Projects. In this video, we are going to explain about a project titled Improving TCP Congestion Control with Machine Intelligence. So now coming to the introduction part, the integration of machine intelligence into TCP congestion control is a promising avenue for enhancing the protocol's efficiency and responsiveness. The research aims to investigate different machine learning approaches and their applicability to TCP, with the ultimate goal of developing a novel, intelligent congestion control algorithm. Through experimental evaluations and real-world testing, the paper seeks to demonstrate the effectiveness of the proposed approach and its potential to revolutionize TCP congestion control for modern networking scenarios. Machine intelligence offers the potential to learn from historical network data, identify patterns, and optimize TCP parameters to achieve better performance and resource utilization. So now coming to the objective part for this project is the research endeavors to advance the state of the art in the network communication protocols, contributing to more efficient and responsive data transmission across the internet. By addressing the limitations of traditional TCP congestion control, the paper seeks to pave the way for a more robust and adaptable TCP protocol capable of maximizing network resource utilization and ensuring reliable and seamless data communication. Through rigorous experimental evaluations and real-world testing, the study seeks to demonstrate the efficiency, practicality of integrating machine intelligence into TCP, showcase its capability to revolutionize TCP congestion control for modern networking environments. So now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirement. In hardware requirement, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. So now coming to the methodology part, first upload network dataset. In this step, the user uploads a network dataset that contains information about the network conditions such as bandwidth, latency, packet loss rate, and other relevant parameters. This dataset serves as the input for the algorithms used to improve TCP congestion control. Second, pre-processed dataset. Once the network dataset is uploaded, it undergoes pre-processing to clean and transform the data into a format suitable for training and testing the algorithms. It may involve removing outliers, normalizing the data, and splitting it into training and testing sets. Third, run RLTCP algorithm. The RLTCP stands for Reinforcement Learning TCP algorithm, is an intelligent congestion control algorithm based on reinforcement learning principles. It uses an agent that interacts with the network environment, observes its current state, example available bandwidth, packet loss rate, and take actions, example adjusting the congestion window to maximize a predefined reward signal. The RLTCP algorithm is executed using the pre-processed network dataset to train the agent to make optimal congestion control decisions under different network conditions. Fourth, run LPTCP algorithm. The LPTCP, machine learning based probing TCP algorithm, is another intelligent congestion control algorithm that utilizes machine learning techniques for congestion management. Unlike RLTCP, the LPTCP algorithm may use supervised or unsupervised learning approaches to learn from the network dataset and predict the best congestion control actions for different network states. Fifth, loss and throughput graph. After running both the RLTCP and LPTCP algorithms, the performance of each congestion control approach is evaluated and compared. To assess their effectiveness, the loss and throughput matrices are commonly used. The loss matrix indicates the percentage of lost packets during data transmission, while the throughput matrix represents the amount of data successfully transmitted per unit of time. So now coming to the execution part, to execute the project, first we need to open the code folder. So here we have a folder named as PyCache. In this we have a Python file containing the Python script in it, and another folder named as dataset containing the dataset over here, that is .csv file, and another folder named as models. So here we are containing dataset over here, and in this agent and main file, these two are the Python files which are containing the Python scripts in it, and here this is the main Python file. This is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. So here this is the graphical user interface. With this we are interacting with the program. Now click on Upload Network Dataset button to upload the dataset for getting the output. Select dataset over here and now click on Open button to load the dataset. So here on this screen, dataset loaded. And now click on Pre-process dataset button to remove missing values for getting the output. So here on this screen, pre-processing completed and dataset contains 1000 records. And now click on Run RLTCP algorithm button to train RLTCP for getting the output. So here on this screen, you can see that x-axis represents simulation time, and here y-axis represents CWND window size. And for each packet sending, we got learning or prediction rate for existing new repo, blue color line, and purpose RLTCP green color line. And in this graph, we can see RLTCP got more packet prediction compared to existing new Reno, as RLTCP prediction time is less, so it can process more packets and its throughput will be high. So now closing this graph, here on this screen, RLTCP loss is 0.054 and its throughput is 99%. As it is processing more packets due to less time in prediction, so its throughput will be high. And so now click on Run LPTCP algorithm button to get the output. So here on this screen, we can see TCP, LPTCP, that is in green line, is also better than existing new Reno to handle congestion. And now closing this graph, here on this screen, you can see that RLTCP we got throughput as over here 97%. With LPTCP we got 0.97%. So RLTCP is better than all other algorithms. And now click on Loss and Throughput Graph button to get the graph. Here in this graph, x-axis represents algorithm names and y-axis represents loss and throughput, where orange bar is for RLTCP and blue bar is for LPTCP. And in both algorithms, RLTCP got high throughput and less loss. So we can say with RLTCP we can improve congestion to get loss and high throughput. So now closing this graph and coming back to the conclusion part. In conclusion, improving TCP congestion control with machine intelligence has contributed valuable insights into the potential of machine intelligence to revolutionize TCP congestion control. The findings of this research provide a strong foundation for future developments in this domain, and it is expected that the integration of machine intelligence into TCP will play a crucial role in shaping the future of network communication protocols, enabling more efficient, reliable, and adapted data transmission across the internet. The intelligent congestion control algorithm developed as part of this study has shown promising outcomes in achieving better throughput, reduced latency, and improved congestion management.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.